Okay, you guys, today's lesson it's an 11.4, but we're still doing surface area. We're doing surface area of a sphere. This is a very, very easy one, so it shouldn't be a long lesson at all. So let's draw a sphere for ourselves. And I guess you could say to make it look 3D-ish, we'll go like this, and then we'll just go dot, 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 center. There you guys go. And obviously I'll put an R for my radius. All right, so your formula, since my marker is now starting to die, for a surface area of a sphere is really easy. You're just going to tell me it is 4 pi r squared. So there is your formula, straight formula for surface area of a sphere. Now, just understanding some terminology. What they do here is I can have a plane, and you'll see this in your textbook as well. And I can draw a plane and I can intersect my circle. I can intersect it at a point and I can intersect it at a circle. When I intersect it at the circle, if the circle is at the center, what they say is the intersection is called a great circle. So this intersection, if it's at the center, it's just terminology and it's really simple, is called the great circle. So if the intersection of the plane and the sphere, if it's at the center, it's what we call a great circle. And all you really have to know with the word great circle is the great circle has the same center, therefore the same radius. That's all you really need to know. But main thing I want you guys to know is it does separate the sphere into two congruent halves called, and this is what I want you guys to make sure you're aware of, hemisphere, because we do need to know the hemisphere. So it separates them into two congruent hemispheres. So if I were to draw it, because I can ask, you have to also know the hemisphere question. God, that's not the best. That is definitely not the best. Why can't I draw it? Let's pretend that it was not there. Let me try to draw this hemisphere once more. There we go. It's a little bit better. So picture that's the hemisphere, it's half. Now, anytime I mention to you a hemisphere, I want you guys to consider the hemisphere closed. Well, what does that mean when I say closed? When I mean closed, it means obviously you're covering half the hemisphere. So half the hemisphere is 2 pi, correct? Half of 4 is 2 pi. But what you have to, this is what I mean when I said closed, you want to cover the bottom. And the bottom's a circle. So if that's the case, and you would tell me that, okay, half is 2 pi r squared, and then this additional thing we're covering is just a circle, which is pi r squared, you could say the surface area of a hemisphere is 3 pi r squared. So think of it that way, unless told it's like open. And you'll see in your examples. Okay, so hopefully that should be pretty simple. Let's take a look at a few problems. So number 1, find the surface area of a baseball. So let's write our formula as always. So we have surface area equals 4 pi r squared, because it's of a sphere. And it says the circumference is 9. So obviously your formula, which is super easy, all it needs is the radius. So let's write our circumference formula. And then let's just input the circumference. So if it's 9, you guys want the radius. What you have to do is obviously you want to divide by 2 pi. But be careful, when you're putting this in your calculator, you need parentheses. Otherwise, the calculator isn't going to calculate it for you correctly. And you should get your radius to be 1.4323 something. Remember, never round. So I want to the nearest tenth. So take what you guys have in the calculator. Square that number, times it by 4 pi, and in the end, you guys should get 25.8, we'll say inches squared. It's a really simple formula. Okay, hopefully that made sense. Number 2, So again, we're dealing with surface area of a sphere. We're going to work backwards. Super easy. Let's write our formula. And then all you're going to do is put your number in. This problem should be very simple for you guys. 4 pi r squared. Beautiful thing, my pi's can cancel. Divide by 4. I believe you get 225 equals r squared. Square root. Radius equals 15. Okay, hopefully so far so good. Okay, number 3. So now it says the area of that great circle is approximately 130, and they want us to find the surface area. So I'm going to write my surface area formula down one more time. So what we want is the radius of that. Well, again, what we need to know is the radii are the same. So remember, the area of the great circle and the sphere, they have their radii are the same. So let's figure it out. We have 130 equals pi r squared. Let's divide by pi. And you get r squared equals, let me get my calculator, 130 divided by pi. So you get r squared equals about 41.38 something. So let's square root that. That's not right. Let's square root that one more time. Shoot. And you get r to be approximately 6.4327 ... All right, let's take that. Let's put it in right there. Okay, let's square it. Let's times it by pi. And then let's times it by 4. Oh, I see. And yes, you get surface area equals 520. I hope maybe some of you guys noticed this and this is the same. I was doing it differently because your textbook did it differently, but I guess the textbook rounded this number early, which I don't like you guys doing, so don't do that. I guess just watch for on your homework if the numbers are a little bit off for this one. I do not like you guys rounding early. Your textbook, this problem is from the textbook. They rounded early and they must have used 6.4, so they got a different answer. Please don't round early. Okay, last one. Find the surface area of a hemisphere. So now we're talking about hemisphere. You know it's 3 pi r squared. Remember, it's closed unless I tell you. So we have a 3, we have a pi. If my diameter is 5.6, my radius is 2.8. So we're just going to put that in. And we're going to calculate to the nearest tenth. So 2.8 squared times 3, oh my god, times 3 times pi. And we get about 73.9 units squared. Okay, really simple for a sphere. So then what I want to do for the last 3 questions is just talk about, take us no time at all, the composite figures here, because those are the ones you have to make sure you obviously are aware of. So let's just do these quickly for your composite figures, and then you guys are done. Let's find them to the nearest tenth. Actually, let's make our lives a little easier because we want to kind of finish. Let's do exact. Remember, exact means you want to keep the pi's and whatnot in there. Okay, so as always, what I recommend you guys doing is writing what this is. You have now half a sphere, an actual half a sphere, not a hemisphere in this case because you're not covering that bottom, plus, well, we can say a cylinder. I spelled that wrong, something's not right. Cylinder. Now be careful, you might want to write only one base. You know, talk yourself through the problems as you're doing it. And now you just have to write what you want. So if a sphere is 4 pi r squared, half a sphere is 2 pi r squared. And then if you guys remember your formula for cylinder, we have 2 pi r h plus, now normally we would do 2 pi r squared because 2 bases. But in this case, we only have 1 base. And then all you got to do is put your numbers in. You got a 2, you got a pi, I got 10 squared, stop, plus 2 pi, radius 10, height 18, plus pi 10 squared. Okay, and then the nice thing about this is just put all that in the calculator. Don't touch pi. And you get 660 pi. Pretty simple. Okay, let's take a look at our next one. So the same thing we have here. Let's write what we have. This top, we have half a sphere, an actual half a sphere. Plus, you have a cone. We can say no top again. Or no base, I should say. No base, because if you remember, surface area, you're usually supposed to include your bases. Okay, here we go again. So surface area, 1/2 again. So we know it's 2 pi r squared plus, careful, the cone, remember it's pi r L. Don't forget that. I don't need to put a base with it. So 2 pi radius 6 squared plus pi. The radius of the cone is 6, my slant heights. Remember, this right here is the slant height. So I have to sit here and find my slant height. 6 squared plus 12 squared equals x squared. Okay, so we have 36 plus 144. You guys should get x squared equals 180. And then you guys should simplify and it becomes, 6 radical 5, because it's the square root of 36 goes into it. So we put that here and we get 6 square root of 5. Again, put everything in your calculator. When you guys put this in your calculator, you should get 72 pi. Remember this, you're going to do 6 times 6, 36. 36 times pi is 36 pi. And then trail the rad 5. Again, hopefully that makes sense. You're just working your way around your figures. Okay, so for this one, you have to do a little bit of thinking. So for this one, again, picture real life present. I'm going to do the cylinder first. But if you guys remember, we want a cylinder one base only. Now, in all of these others, like you had a sphere outside, you had a sphere like added on top. In this case, we obviously want to go inside. So if we're going inside, try to just remember you're covering this. We're going to say that this is open. Otherwise, you'd have to have it closed, obviously, because you would be covering the top. So if you're covering the inside, you're just doing this, which is half a hemisphere again, or I should say half a sphere. Let's write it as half a sphere. I thought this one was a little more challenging. It's not. So you want to cover inside. Picture you're going inside the sphere. So here we go again. Cylinder, 2 pi r h plus pi r squared plus, and then we have 2 pi r squared. So we got 2, we got a pi, we got the radius of 5, we got a height of 9 plus pi radius 5 squared plus 2 pi 5 squared. Pretty simple, these problems. I'm hoping you guys are feeling the same way. 165 pi. And that's it. Hopefully you guys found this one easy. Obviously, some are more easy than others. Some are a little bit more challenging, which is why they take a little bit longer. All right, you guys. Bye. Oops.